So this is part 4 for the final test read from last semester. Let's look at what's going on the picture right here first. You can see that the box mass M is actually sliding down the ramp. And when it comes to the ramp, the box itself right here, mass M, we have the velocity at 3.5, initial velocity. So question 1, they were asking you to determine the height of the block M. So you're gonna have to utilize, okay, just go ahead and do A. You're gonna have to use the concept of conservation of energy. So at the highest point, we only have potential energy is equal to kinetic energy. mgh is equal to 1/2 mass times velocity squared. So now we're looking for the height. So you're gonna have to go ahead and replace every values. Since we were only talking about mass M, so I'm just gonna go ahead and substitute this smaller mass. It's just a big M, okay? So it would be mgh, right? Is equal to 1/2 m. This is the final velocity, and the final velocity they were telling us is 3.5 initial velocity squared. So now you're looking for the height since they have the same mass, and get rid of that. So height is equal to 1/2 g 3.5 velocity squared. This is the answer for your height. So when you want to determine the the speed, the topic is called conservation of energy. Now look back at question B. Determine the speed after collisions of the block M. Let's go back to see what question. So as you can see labeled in the yellow color, we don't know what the final velocity of small block M is. That's why I'm putting a question mark there. But however, we do know the final velocity of the block of the mass 1.5 m, which is 2 times initial velocity. So with that being the case, and actually helping us a little bit in order for us to understand, we're gonna have to use conservation of momentum, which is 1 pi is equal to Tf. P stands for mv, which is momentum, which is mass times velocity. Mass times velocity final plus mass 2 times velocity to final. As you can see, I have every single term because after collisions, the block doesn't stick together, just like what it says on the diagram. Even though you don't see the question just yet, but you should be able to realize that the box does not stick together. Okay, let's interpret what's going on first. So, look at this question. I think for this question, I'm gonna come back later. Okay. Let's move on to this to the second part of the equation first. So I'm just gonna go ahead and do C right here. Determine the friction, the coefficient. So you're gonna have to draw a free body diagram, which is the Newton forces. I hope you still remember how many forces are acting upon the object. The object is sliding this way, but there's no force pushing beside the force due to the gravity, so the object itself has mg. And this is 1.5 m. So therefore, this force right here, I'm gonna go ahead and label them as 1.5 mg. That's the force due to gravity. Also, we also have the force of acting upon, exerting from the floor, which is normal force. And then the surface is so rough, they have coefficients. So frictional force is equal to mu n. That's what you need to know. And then we're gonna have to understand what comes